So you guys get the point. So let me get to my presentation. So my speech is about vehicle design, and as you can see from the video, they put it through a lot of tests. They try to figure out ways how to destroy the car as much as possible, so that when you're driving, nothing like that happens to you. So, if you think about cars, their main purpose is to try to get you from one point to the next, but then you don't really think about safety. Safety is actually a really important factor, because if cars weren't designed for crashes or accidents, you guys wouldn't be alive if you guys got in a crash. In Cal State LA, it's a commuter college, so most people either drive or take the bus to school. So basically, safety is an important factor, especially since traffic is a big problem in LA. When you drive to school, there's a lot of traffic, there's a lot of bad drivers, people cut you off, and accidents happen. Well, engineers put safety first. That's one of their main points when they design a car. They put it through a lot of tests and design it so that when you get in a crash, you know it's safe. The three main points I'll be talking about today are assessing the problem, designing the problem to correct the problem, and testing, or actually I'll be showing you how it works in your car. So assessing the problem is going to be my first main point. The problem is that accidents are really common in the world. And in America, according to the Association for Safe International Road Travel, America has 2.35 million accidents that result in injuries, and 37,000 of them result in deaths. Worldwide, it's 50 million injuries and 1.3 million deaths. Well, some of you might be seeing this and you guys might be kind of scared that if you drive, you're going to get an accident. If you do that math, it's actually 2.6% chance that you're actually going to die. So engineers are doing a pretty good job. Well, designing the vehicle. Next, I'll be moving on to design a vehicle. Engineers have a 5-step process that they follow when they start designing something. The process starts off with define your requirements. This is basically what your client wants or what people want in their initial design or their final design. Research is the second one. This basically means that for your design, you have to do the research, maybe look at past designs, maybe see that there's new materials out in the market that might be more efficient than some. Well, for example, cars all have frames. That's what keeps them intact. If you're in an accident, that's what protects you and your passengers. When you're researching a frame, you're going to be thinking about, let's find a really strong material. Maybe like steel, maybe titanium. What would be the better choice? Most likely steel, because titanium is really expensive. And you also want something that's lightweight. So that's why you go with multiple designs. With multiple designs, you can test multiple different prototypes. If, let's say, you have multiple members on your team that want to go different directions, they can each build a design and you guys can test which one is the most efficient. Obviously, the one that costs the least amount of money and does the same thing. Analyzing the design is basically testing it. What usually engineers do is they test which points on the car are structurally weak. Maybe they crash it like in the video, or they place large loads on different parts of the car or the frame. So let's say the center of the frame is weak. If you get an accident, that's most likely where it's going to break. And lastly, it's finalized and redesigned. What that means is if you like the design and it's cost effective and your clients like it, then you're basically finished to move on to mass producing it. If not, then you basically have to go back, redesign, start from the beginning. So it's all up to what you really want to do or what engineering wants to do. Now that I talked about the design process, I want to talk a little bit how these technologies work in your car. The first one, I like to show a video, which is blind spot detection. As you can see, the car sneaking up on the red car, you can't really see it. Usually when you're driving, you're not really looking at that direction. It's called a blind spot for a reason. So when it approaches the blind spot, it actually has a really bright light that shows you that there's a car coming up from behind you. The guy's trying to turn, but then the car's like slowing down the car and preventing it from switching over and potentially crashing into that car. This is some of the new technology that are in many high-class cars, and you're seeing it more in the lower-class cars as well, because it's getting cheaper and cheaper to produce. For emergency response, that's basically like what you see in some commercials where they talk about OnStar and stuff like that. Rollover protection is basically, in conclusion, engineering process helps design more safe cars.